and do two more examples for the same section, 6.3. So the first one I want to do is I want to find the trig functions for when tangent of theta is equal to 3 over 4 and when sine of theta is less than 0. So in here again we're looking for all trig function values. Meaning I'm looking for sine of theta, cosine of theta, tangent of theta, secant of theta, cosecant of theta, and cotangent of theta. Let's go ahead and write out those. So sine of theta, we're looking for cosine of theta, and we're looking for tangent of theta, we're looking for cosecant of theta, we're looking for secant of theta, and we're looking for cotangent of theta. So ultimately, these are what I'm trying to look for. So in order to do that, let's go ahead and go back to the tangent of theta. We know tangent of theta is equal to 3 over 4, meaning that this is positive. And we know that sine of theta is less than 0, meaning that this is going to be negative. We know that tangent of theta is equal to sine of theta over cosine of theta. So again, this is equal to 3 over 4. Sine of theta is related to the y, cosine of theta is related to the x, so then 3 is related to the sine, and 4 is related to the cosine. In this case, we know sine of theta is less than 0, so if I have tangent of theta equals sine of theta over cosine of theta, I know that the numerator is less than 0, meaning that it's negative. The only way I'm going to get a positive tangent, which we have here, 3/4 is positive, and a sine that's negative, is if I take this and I divide it by another negative, meaning cosine is also going to be negative. So what's the relevance of this? This is going to tell me what quadrant I'm in, and the quadrant is going to tell me about the signs for each of these sine, cosine, tangent, cosecant, secant, and cotangent. So let's go ahead and draw a picture of what this would look like. So if sine is negative and cosine is also negative, this first quadrant is positive, positive, this one's negative, positive, this one's negative, negative, this one's positive, negative, meaning that for this tangent and for sine of theta is negative and cosine of theta is negative, we're in the third quadrant. So then we're going to go ahead and go back and we're going to draw our angle somewhere in the third quadrant. So theta we know is somewhere in the third quadrant. So in order to do that, let's go ahead and use a 3 and 4. So sine of theta we said was related to the y, so that means that the 3 is going to be the y value. And for cosine of theta it's related to x, so this 4 I'm going to use as the x value. So I know that when we're in the third quadrant, they're going to be negative, so again, cosine of 4, make it a negative, and sine of 3 and make it a negative. So the point is going to be -4, -3. So we're going to go ahead and use this in order to find the trig functions. By first, let's go ahead and draw the angle. And our angle is always going to be formed by this point that we come up with and this center or the origin. So this is my angle, and we're going to go ahead and drop a perpendicular. So that gives me a right triangle. So in order to find sine, cosine, tangent, cosecant, and so on, what I'm going to use is SOHCAHTOA. So that means that sine is opposite over hypotenuse. That means I need to go and find the opposite. I need to find the hypotenuse. For the cosine, I need the adjacent, and I need the hypotenuse, and so on for the tangent as well. So I'm going to need the opposite. That means opposite of this angle is this distance here. This distance we said was equal to 3. Notice that I'm ignoring those negatives for now. I'm going to use another acronym, another trick, in order to figure out what the signs would be. So for now, we're going to make them positive. And now the adjacent, this is a distance on x's, so that's an x value of -4. The distance is equal to 4. Now to find the hypotenuse, we're going to go ahead and use the Pythagorean theorem. 3 squared plus 4 squared is equal to c squared. So I'm calling this one c. That means that c is equal to, or c squared is equal to 25, which means c is equal to 5. So this distance is equal to 5. Now we're going to go ahead and use this picture to find the sine value. So sine is opposite over hypotenuse. Opposite is equal to 3. Hypotenuse is equal to a 5, so 3 over 5. We know that sine of theta is less than 0, meaning this should be a negative. So we're going to go ahead and make it a negative. Now, what I can do in order to determine the signs for the rest of them, including this one if I wanted to, is I can use this acronym, all students take calculus. So this tells me that for this particular quadrant, the tangent is only one, tangent and its reciprocal, that are going to be positive. So both of these are going to be positive. Everything else is going to be a negative. So let's go ahead and take care of the signs right now so that we don't forget about them later. So cosine is adjacent over hypotenuse. Adjacent is 4, hypotenuse is equal to 5, so it's negative 4 over 5. And tangent is opposite over adjacent. Opposite is 3, and adjacent is equal to 4. Cosecant of theta is equal to, we already took care of the sign, so take the reciprocal of 3 over 5, that's equal to 5 over 3, so negative 5/3. Secant of theta is equal to negative 5 over 4, and cotangent of theta is equal to positive 4 over 3. So that means that the trig function values are these right here. Let's go ahead and do one more example, and for the next example what I want to do is I want to use the even-odd properties. So for the even-odd properties, we know that sine function, the sine function is going to be an odd function, and we know that cosine is an even function, and we know that tangent is an odd function. So how do we know that each of these, whether each of these is odd or even? So if sine of negative x is equal to negative sine of x, this is equal to odd. If so for the cosine function, cosine of negative x is equal to cosine of x, and for the tangent function, tangent of negative x is equal to negative tangent of x. So if you remember from a few sections ago, the odd functions were if f of negative x is equal to negative f of x, then we had an odd function. For the even functions, we were finding f of x equals f of negative x, or f of negative x is equal to f of x. So in this case, my f would be sine, and so sine of negative x is equal to negative of f of x. And you could do the same thing for each of the other ones. So we're going to go ahead and use these even-odd identities. Make sure that you memorize all of these even-odd identities. Basically, this whole worksheet you do have to memorize. So the periodic properties, the reciprocal identities, the quotient identities, Pythagorean identities, and the even-odd identities. So let's go ahead and do an example using this. So the first example is to find or simplify sine of negative pi. So for this one, it's easy enough to go ahead and count. So if I have a negative angle, I go down instead of going up around the unit circle. So if I go down, I'm going clockwise instead of going counterclockwise as I usually would. So sine of negative pi, let's go ahead and do it that way, just to get the idea going. So negative pi, that would be, I start here, and instead of going up, I'm going to go down by pi. So if I go down by pi, I would end right here. The point related to this angle would be -1, 0. The sine value would be the y value. So this means that sine of negative pi is equal to 0. Now let's go ahead and do this with the even-odd properties now. So for sine of negative pi, we know that because sine of negative theta is equal to negative sine of theta, so let's go ahead and write that down too. Sine of negative x is equal to negative sine of x, or theta, you could use either one. We're going to go ahead and change this into negative sine of pi. So basically what happens is that this negative comes out to the front, and again, that's because it's an odd function, or an odd, it would be an odd function. So then this gives me a negative, and now we're going to go ahead and find sine of pi. So sine of pi would be the angle, or pi would be the angle going up away from the x-axis, so going counterclockwise. If I go pi around, it lands on exactly the same place. So this point is exactly the same thing as before, -1, 0. So that means that the sine value of that is equal to 0. So if I simplify, I still have a negative, and negative of 0 is still equal to 0. So my answer, sine of negative pi, is still equal to 0. Let's go ahead and do one more example. So what if I had tangent of -39 pi over 4? Well, for this one, I don't want to sit here and count out 39 of these pi over 4s. So what we would do if we wanted to count is we would break this unit circle up into pieces of 4. So 4 pieces on the top, 4 pieces on the bottom. And because it's negative, I would start here and count going down. So this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4, negative 5 pi over 4, and so on until you get to negative 39 pi over 4. That takes too long. So what we're going to do is we're going to use the even-odd properties for the tangent. We know that tangent is an odd function, so that means that tangent of negative x is equal to negative tangent of x. So we're going to go ahead and use this rule here. So tangent of negative x equals negative tangent of x. That means that I can simplify this to negative of the tangent of 39 pi over 4. Now I have to find the tangent of 39 pi over 4. Now this becomes a problem that we've done before. So 39 pi over 4, it goes over this unit circle more than once. So let's go ahead and find out how many times it goes around that unit circle. So we're going to go ahead and divide the angle, 39 pi over 4, divided by 2 pi, because we're trying to find out how many full revolutions does this angle go through, and then how much extra does it go. So this is equal to 39 pi over 4 times 1 over 2 pi. Cancel out the pi, and you're going to get 39 over 8. So if I divide 39 divided by 8, I'm going to get 4. That gives me 32. You subtract, you get a 7, and then that's going to give me 7 over 8. So 4 and 7/8. So it's going to go around the unit circle 4 times and 7/8 of another full revolution. So that's what that would mean. Now what I'm going to go ahead and do is I'm going to go ahead and rewrite that 39 pi over 4. And this is equal to 4 of those full revolutions, so 4 of those 2 pi's, plus 7/8 of those full revolutions. So if we simplify, we're going to get back again 4 of those full revolutions. I'm not going to simplify this one, but if I simplify this, I'm going to get 14 over 8, or in other words, 7 pi over 4. So, plus 7 pi over 4. So this means that the negative of tangent of 39 pi over 4 is equal to, we still have the negative of tangent of 4 of these 2 pi's plus 7 pi over 4, which is equal to negative of tangent of my reference angle. So my reference angle is 7 pi over 4. So let's go ahead and use 7 pi over 4 now as my reference angle and take the negative of that to find the tangent. So 7 pi over 4, this is 1 pi over 4, 2, 3, 4, 5, 6, 7 pi over 4. So 7 pi over 4 lands here. So the point related to this one is radical 2 over 2, comma negative radical 2 over 2. So the tangent of this angle is negative radical 2 over 2. We still have the negative, so let's keep the negative on the outside. And then the numerator is the sine value, so that's negative of radical 2 over 2, and the cosine value is radical 2 over 2. So then if we simplify, negative of a negative gives me a positive, so these are going to go away, and we're going to get radical 2 over 2 over radical 2 over 2, which gives me back a 1. So my final answer, tangent of negative 39 pi over 4, is equal to 1. So that would be my answer.